All right, guys, you will need it'd be handy to have a calculator, so if you need to type stuff in or get used to typing some of the stuff in, that works just fine. Because when we look at problems 1 through 3, or not 1 through 3, 1 through 5, we want to evaluate each expression for -2 and 3. So we're evaluating for both terms. Is there one of these in particular that y'all want to look at?
5.
Number 5. 1/5 to the x plus 2. Whenever you're typing them in, I would type them in exactly as you see it. 1/5 to the x plus 2. So I'm going to use the 30xs here, so we can say parentheses 1/5 to the x plus 2. Which would indeed be 1. -5 to the -2 plus 2. If you're not sure with how to type it in, type that value in, replace it with parentheses. So we'll put parentheses around it. Now the other one was 3. Parentheses 1/5 to the 3 plus 2. .00032. All the ones we will have, they will round nicely to 3 places. I say that because this doesn't actually round nicely to 3 decimal places. Because if we did round this to the nearest third decimal place, it'd just be 0. So here, I put it on the answer key is 0.00032.
How do I get it?
So you can use the caret key.
Well, on the DI-84 or whatever.
You can use the caret key.
Oh, heck, I didn't even see that.
Yep. And a lot of these here, it's almost going to be nicer to just use the 30xs with a lot of it. Because for fractions with the graphing calculator, there's nothing wrong with using it. Alpha y equals enter. We got to do that each time. Whichever one you feel more comfortable with, do it. 2 to the 5x minus 2 to the x. 2 to the 5x minus 2 to the x. In both cases, we're just replacing x with -2, because that's one of the values it asked for. Enter. We can round to 3 decimal places, -0.249.
What am I doing wrong? I'm not getting it.
Because we have to set x,
Oh, to 3?
because it asks for which 2 values.
3 and -2.
So we do -2 first. So I typed it in with replacing x with -2, found its value. Now we're also going to say 2 to the 5 times 3 minus 2 is 32,760. If you want to put a comma between them, just make sure that it is obvious that those 2 are distinct numbers. Don't just stick them right next to each other and they look like one continuous number. But that's it. Any other questions on 1 through 5? 6 to the -x minus 1. I can do this with the 30xs if we want, or the TI. 6 to the -x minus 1. Or 6 to the -x minus 1. And we have this here.
So you have to get the
Well,
1.7.
it's doing scientific. Because here it's, for some reason, do it in scientific. 6 to the negative x minus 1. This is here. If for some reason you converted it over to scientific form, it really didn't need it. Most of the time, we don't even have to worry about it. Normal. Because here I'd have to go in and force it to try to do that, but we'd have to move the 0 the other way. Without messing with this, because I could get it. Let's see here if that would. Yeah, there's something in here. I really don't think English is going to be the ticket. No. Yeah.
How does it make it any different?
It's based off of how we set the numbers up, how they want it represented. Yeah. But I haven't tried all of them in the graphing calculator for the test, but the 30XS will give us all decimals. It's not going to give us any scientific. We're not going to have times 10 to a number. We have to rewrite it back out. Questions on 1 through 5? We good with 1 through 5? Yes?
Yeah.
6 through 11 aren't going to show up. I was planning on having those be a part of the test, but none of them ended up showing. I just ended up forgetting to put them in. Might as well keep these be the same. Log base b of y equals x if and only if b to the x equals y. And the natural log of y equals fx if and only if e to the x equals y. This is the first way we went about doing these, switching from one to the other. So these first set here, we want to rewrite the logarithmic form in exponential. Log base 9 of 6,561 equals 4. Which would be 9 to the 4th equals 6,561. And that's it. And if we wanted to, for this here, since it's all numbers, 9 to the 4th is just a number, we could plug 9 to the 4th into the calculator and see what we get. If there are variables, if it had said 9 to the 4th equals x, we could plug 9 to the 4th into the calculator. It's not going to tell us much because the other side is just x. Now we did learn later on that if I put, for the next one, log base 5 of 78,125, if I put it to the base of 5, well, 5 to the log base 5 do what? Cancel out. And if I put one side to that base, we've got to put the other, which is really telling me 5 to the 7th is equal to 78,125. I have no idea why I kept switching between the two, but that's it. Those are the two main ways we can flip. Does that make sense? But that's all we're doing with this here. Because 14, we'd have 1/7 to the negative 4 is equal to 2,401. Questions on this here? So what do we think the next one would be? 15 to the 1st is equal to? And realistically, these two formulas are the exact same. It's just with the natural log, our base is set at e. I think the next set is the natural log, yes? What do we think the ln of x equals 7 would be? E to the 7 equals x. Well, our other method, kind of as we showed on one of them, when we put, so natural log, when we put its base, what the base of the natural log is, so e to the ln of x, well, the e and ln will cancel out, yes? But what I put to one side, I put the e to the other side. So we have e to the 7th, that doesn't simplify, it's just e to the 7th. The other side is just x. We can do the same thing on the next one. E, which will tell us what? E to the equals, how about 18? E to the y equals 71. And the last one, e to the 9th equals x. All the natural log ones will have a variable somewhere located in it, and that's because, well, e is an irrational number. It's a non-repeating, non-terminating decimal. So if we tried to put something other than a variable in, it won't make a true statement. It would just be all approximations. Does that make sense? Because the first one, e to the 7th, e to the 7th is this here. So questions on these here, going from logarithmic to exponential. We good with these here? 8 of the questions on the test will be this, going from logarithmic to exponential. 32. If I remember right, 8 of the questions are going from logarithmic to, or exponential to logarithmic. You have 8 going from logarithmic to exponential, you have 8 going back. So if we look at the first one, 3 to the 4th equals 81. So we have log base 3 of 81 is equal to 4. And again, just like with the last one, we can apply that log base because, again, we're trying to get rid of this exponent. So here I'd apply log base 1/5 to both sides. Doesn't matter which side we write it, because I'd have log base 1/5 of 1 over 125 for the one side, yes? Questions? The other side, log base 1/5 of 1/5. That is, cancels out and simplifies out, yes? Leaving us with the exponent of 3. Now, we did find a way, especially in the graphing calculator, math, log base, and we could type in log base 1/5 of 1 over 125. All numbers, and if it tells us it's 3, we have this set up correctly. Questions on these first two? Questions on these here? Okay. But again, the switching method still works. Switching method still works. This is just another way to get to it. Because if we looked at the next one, 125 to the 2/3 equals 25. If we did the switching method, this would be log base what? 125 of 25 equals 2/3. That's it. So it's just the exact opposite of what we did to go from logarithmic to exponential. Yeah, logarithmic to exponential. Now we're just going back. E to the x, e to the 4 equals x. Well, this would be ln, because when we have a base of e, we're automatically with natural logs. Our ln This would be ln of what? X equals 4. Because we're just applying, what we did was, if we wrote it out, was applied the natural log to both sides. ln of e is 1, leaving us with our 4, and the other side is ln of x. Questions on this here? E to the y equals 27. This would be what? ln of 27, the natural log of 27 is equal to y. And the last one, e to the x equals y. Almost. ln of y equals x. Yep. That's it. So 16 of the questions on this test are just switching from exponential to logarithmic or logarithmic to exponential. Questions on these here? $32, I believe. Evaluate each logarithmic and evaluate each of these and round to 3 decimal places. Which one of these do we want to look at first? 28. Log base 10 of 0.00001. Whenever the base 10 is understood to be a common log, yes? So, I'll use a graphing calculator for this. I could say log of 0.2341, yes? Enter. Is -5. Now we could go math, log base 10 of 0.12341. With log, if the base is 10, it's our common log, we can just use the log button. Do we need to technically round this one to 3 decimal places? No, there's no decimal after it. It's just -5. If it comes out to a nice number, we don't have to simplify it or round to 3 decimal places. Which one do we want to look at next?
How do you use math?
Math. Yep. 26. Log base 5 of what over 125? Well, math. Log base 5 of, I think it was 1 over 125.
Yep.
That's it. Now we did have the change of base, which stated log base b of x is equal to log of x over log of b. We could do that also and get the same thing. Or we can just type it in. Any other questions on 26 through 31? Question? No? No clue. 31. With any of these here, especially, I mean, no matter what they are, type them in exactly as you see them. Because we have ln of 4 to the 6th. Yep. 8.3177, so 8.318. We just round it. If you're not sure if you round it or going to round it right, you want to give me 4 or 5 places. I'll take that. Giving me more decimal numbers out is not a bad thing. All right? Because that way I can see, okay, yes, you did get the whole number. But again, with most of these here, I'd type them in, especially go for log like 26, 27, log base, put the base in, put the number. I would type it in exactly as you see it, let the calculator do it for you. Questions on this here? Expand the logarithm. Quotient. Product. Power. Which one do we want to look at first? 32. So we go quotient, product, power. Quotient says that if we have something being divided inside the log, we write it as subtraction of two logs. What's in top goes first. What's on bottom goes second. Here we don't have a quotient. We don't have division. So we don't use it. We go straight to product. Since we have three things being multiplied inside the log, we rewrite it out as addition. So we'd have log of 6 plus log of x to the third plus log of y squared. Log with those being added together. Power states that what if there are exponents, we move it into the front of the log that has that exponent. So this will just say log of 6. Plus, we move the 3 out front, telling us that we have 3 log of x plus 2 log of y. And that's it. That's as far as we have to take it. Yes. Some math programs in some places will make you take it further or tell you it condenses further than that, because technically we can break up 6 into 2 times 3 and do that there. But we're not taking it farther than this. Now 33, quotient first. We do have something being divided, so we can break it up into log of the top minus log of the bottom. Log of the top minus log of the bottom. Is our quotient. Log of the top minus log of the bottom. Questions on quotient? We go to quotient. Now product is next, so especially if we look at this first one, just like the last one, it'd be log of 7 plus log of x squared. Then we'd have our minus. And we could put the parentheses here, log of y cubed plus log of z squared. But that negative is not being applied to just the first one, it's being applied to all that second half. If a variable or term that's a part of the original logarithm is in the bottom of the fraction, the sign in front of that log has to be minus. That's part of the reason I put those parentheses. Because we can really think of this as this, with both of those being negative. Since we know that if those terms, the y cubed and z squared, are both in the bottom of the fraction, they both have to have that minus in front. So we can put the parentheses around it, then distribute the negative, or remember, bottom of the fraction, those logs have to be minus. And just go on and put it there. Does that make sense? Because the last thing we have is powers. Log of 7, there's no exponent. But the 2 for our x squared is going to give us plus 2 log of x. Minus, the 3 comes out giving us minus 3 log of y. And our 2 for z, giving us minus 2 log of z. And that's it. Questions on expanding? Any other questions on these here?
Second part, when you hear the arrows, just add them.
So we're making that power. We're taking that 3 and moving it to the front. We're moving the 2 to the front. And here are the other 2. We're moving that product. We're moving that, or not product, power. We're moving the power to the front. We're moving the power to the front of it. Any other questions? I have a tendency to draw the arrows just as a reminder to myself this is where it's going. It always jumps right out in front of it. So we don't put it at the very front, we just put it right in front of that log it's attached to. (34). So the first one would be quotient. So ln of 7x cubed minus ln of 16y squared. Quotient. Natural log of the numerator minus natural log of the denominator. Natural log of the top minus natural log of the bottom. Now with this here, we know that the natural log was 16 and the natural log with our y squared, when we break this up, should both be negative. Because they're both on the bottom, they should both have a minus in front. So when we do the product, 7x cubed on top. So it'd be natural log of 7 plus the natural log of x to the third. Then we'd have minus the natural log of 16 minus the natural log of y squared. Both of those will have a minus because both of them are in the bottom. If it's just a single term, it's just minus that and we're done. If it had just been natural log of 7x cubed over 16, we'd have minus the natural log of 16, we're done. We don't have to break it up. Single term. Single term. Last thing we have is powers. We move the 3 up front. The natural log of 7 is by itself. But then it would give us plus 3 times the natural log of x. Minus the natural log of 16. Minus the 2 would move out front, giving 2 ln of y. Questions on these here? All right, let's look at condensing. Condensing. Powers, product, and then really simplify. If there's any negative exponents, we got to make them positive. Just put them in the denominator. Because the first thing we're going to do is powers. So on the last step of the previous ones,
What's that second one say?
product, we took the exponent and move it out front. To condense, the first thing we're going to do is take the number out front and move it back to an exponent. We're putting it back. So the first one would be, log of x to the 6. Next one, we're going to move the positive 5. Give us plus log of y to the 5th. And the last one, we're going to take the negative 4. Plus log of 3 to the negative 4. Because when we do the powers, we're taking the number and its sign. Because if it's positive, it just looks like we're taking the 6 and 5. But if it's minus, we take the negative with it, which turns it positive. Okay? Now we have 3 things being added together. And according to our power property, we can write it as a single log with what's inside being multiplied. X to the 6th times y to the 5th times 3 to the negative 4th. Now we can't leave exponents negative. 3 to the negative 4th has to be moved from the top of the fraction to the bottom, which makes the exponent go from positive to negative or negative to positive. And in a lot of cases, we'd be done. But 3 to the 4th power. We can type that in and see what it is. It turns out to be 81. And that's it. Questions on 36? Powers. Nope, that's it. We don't have to do anything there. We're just combining it to a single term. So the previous, we were breaking one single term up into multiple. Here, we're moving them all back to 1. 3 to the 4th. Yep. If there's a number to a power, try to simplify it. Try to simplify it. 37 through 40, another one of these we'll want to look at. 37. First thing we want to do is use our powers property, which will tell us that we have log base 4 of x to the 3rd plus log base 4 of y to the 9th. Both of the numbers in front of the logs are positive, so we don't have any real sign things here. Questions on our powers step. We have two logs being added together, yes? So we can write it as a single log with what's inside being multiplied. Do we have any negative exponents? Do we have a number to a power? That's it. We don't have to do anything after that is because we couldn't leave the exponent negative. We had to fix it. And 3 to the 4th was actually a nice number, so we went on and replaced it. Now, if you had something like 15 to the 7th or 8th, that we could, let's just say 15 to the 15th. Don't put that in its place because that's way too big. Does that make sense? And even saying if, especially the evaluating, you got a number like the one above it, the 15 to the 8th, you got to write that whole thing out. Got to write that whole thing out. We only round to 3 places after the decimal. Questions on condensing? Any other ones of those that we want to look at? $38. Powers first. Which would give us ln of x to the 6 plus ln of 2 to the negative 4. We take the negative with it. And now it might be a little quicker to have just done powers and then quotient, but this kind of covers it too. Because now we have 2 being added together, so we can rewrite it as what's inside being multiplied. You didn't have to switch the 2 and x. I just put it this way, just kind of standard form, numbers and variables. But they are being multiplied together. Doesn't matter where the negative exponent is. If there is a negative exponent, we have to make it positive. We can do that by taking the 2 from the top of the fraction to the bottom. Because when we move it from the top to the bottom, the exponent goes from positive to negative or negative to positive. So we have 2 to the 4th. The numerator is still x to the 6th. Now 2 to the 4th does simplify nicely. I believe it is 16, yes? So it's the natural log of x to the 6 over 16. That's it. Questions on this here? Question, we feel good with these here? All right. Because we took the negative with it, so the negative went with it to the top. Since we took the negative away, it goes to positive.
Okay.
Because if I take a positive away from a positive, it's still positive. Mm-hmm. A negative. Mm-hmm. Yep. We feel good with these here. Because we do have this one, and I think some of y'all are working on it. I'm going to just, I mean, to make that Y look so weird. I'm going to go in and write this out. Y'all can keep working on it, but if you want to go back and do this before tomorrow, you can. Two, four. But those are kind of the main steps if you jump through it. That way you can kind of go back and check and see and match up with what you were doing with those there. How do we feel with everything we've covered so far? Our two different evaluating, condensing, expanding, rewriting exponential to logarithmic, and logarithmic to exponential. We feel good with all this here. Yes? Question? Yep. Now, out of all this here, the condensing, really the product for condensing is going to be helpful for solving. Because if we have more than one log, we need to put them together. We need to combine them, and it's going to make it easier to solve. Now, the only thing left on the review sheet, which we don't quite have time for, is the inverses. There's one question on the test for inverses, and that's the bonus. Inverses. Here's if you flip the page. They got out of order. So I will post a video later, quote unquote, full video if I do have time, but I'll make sure to hit the inverses. If I don't quite have time to do the whole thing, I will make sure to especially put one up with just inverses, and then we'll have the rest of it later. Does that make sense? Test is tomorrow. We have covered everything that's going to appear as a part of the test except for the one bonus question.